Hi, everyone. Welcome to this session from Google Cloud. We're going to look at the roadmap for the work we're doing around app modernization, modern tools, developer tools, serverless, containers, all kinds of great stuff. So thanks for joining us today. I think we're going to have some fun, see some demonstrations, give you a sneak peek as to what's interesting and exciting. So thanks for joining us. I'm Richard. I'm one of the directors of product management covering this space. Happy to be your host for today. I'm going to be handing off to a number of great speakers throughout our time together. So let's get started. So first off, this group I'm in is a part of a group that the point of it is to make sure you are being more productive as developers, make sure operators are being more effective through automation and more power and troubleshooting. So really the goal is, can we help you build better software faster? Can we make it cheaper to operate more, let's build more interesting stuff. So it's a lot of stuff in this portfolio if you look at it. So, and we're going to talk about it today. There's developer tools. How do we actually build new software? What do we do with serverless? How do we actually take advantage of serverless for whether it's a serverless build system, functions, serverless containers, things like that? Of course, GKE, our flagship container runtime. We're going to talk a little bit about that, where we're going with that. As well as Anthos, how are we supporting you taking some of these Google technologies and practices and patterns and actually bringing them to other places, which can be pretty exciting. Also part of this story is operations and security and marketplace, a bunch of things. Really, again, the point of this group at Google Cloud is how are we helping you build this great software and helping you operate it. And when you look at it all, it does all kind of connect the dots here. So when you think about it, this isn't just a bunch of individual tools. It is, and you can use them all individually. But we actually work really hard to connect this so that you can think about, well, how do we build this new software? We're going to talk about CAMP, our program that takes some of those DORA metrics, DevOps research and assessment, and actually helps you implement some of those. So how do we think about our products, our portfolio, our practices? Then how do we start building code? How do we migrate existing apps? How do we then build the packages and store them securely? Then can we deploy them to a subset of runtimes and make sure then we operate all that at scale? But that's the point. So we do a good job, I think, of trying to connect those dots and be opinionated, but make sure you can make this extensible. You want to use a different build system? That's fine. You want to send this to a different container runtime? Sounds good. You can use whatever you'd like, but we do try to connect the dots here. And so if I look at this roadmap, and again, you're getting a sneak peek here, some of these things we're going to show you today, we haven't talked about publicly yet. But if we look at the themes of this, like what are we working towards? Is this just a random collection of smart people shipping weird stuff? I mean, sometimes, sure. But mostly what we're trying to do here is build in best practices. So take some of the best practices we've learned running 9+ billion user services at Google, things that we've learned from the industry. How do we build that into the products so that you feel like, wow, I'm not just using some sort of beta or kind of hello world quality system. Like, no, I'm using things that are turned on by default with smart defaults, smart settings. At the same time, this isn't about, hey, here's some wild future platform that maybe you get to use someday, 10 years from now. No, we want to make sure we're offering things that right now are useful, that recognize your existing tool chain, how you work today, right? We want to do things that are familiar, but hopefully better. And then finally, a lot of the work to what I just showed you is about connecting the dots here, that we don't think it needs to be your job to stitch together countless services into something useful. The goal should be that, hey, can we help connect some of those dots? So you get back to building awesome software and not just tweaking a bunch of knobs to connect services together. If you'd like to, awesome. But we're also going to try to do our best to purposely and intentionally connect some of these services. So as you watch over this next hour and a half or so, notice as we go through the roadmap that these are the sorts of things we're trying to do to make it easier for you to build awesome software. So let's look at the first section. So as we look at cloud native development and just modern development, what are we doing in this space to accomplish those things, right? Help you use smart defaults, help you do those things. And I'm a fan of, it's kind of a jobs to be done framework of product management, right? When you think of product management, it's, when we're building things, what is the thing you're hiring us to do, right? What have you hired this dev tool to do? What have you hired GKE to do? Things like that. And so when I think about the jobs to be done for dev tools, you're looking for faster inner loops, right? The stuff that happens on your desktop, your local workstation when you're, hey, not only picking libraries and packages, but you're doing local testing. You're finding out that, hey, this thing I just built locally violates some policy in production. Cool, let me learn that now, so I'm not accidentally waiting till the end to find that out. So that inner dev loop, right? Can we make it easier to write, test, kind of package things up locally on your machine? Secondly, you're I think often hiring these tools to make it easier to use containers. I think we're all doing a lot with containers now. I look at survey data, customer data, I talk to many of you, and what you're doing is, yes, we're trying to embrace containerization as the unit of compute, that makes a lot of sense to you. So can we make it easier? I don't love writing YAML. Like if I don't have to do a ton of stuff here, are there things that we can help with? We're actually going to show you some cool demos here, but what are we doing to help you do containers the right way? And then finally, get some of those best practices. I don't want you wasting your time post-production having to go debug something that we could have helped you catch sooner. So what are we doing to help you do some awesome stuff on the desktop, learning things early, so you're fixing things in the moment, not 2 months later where you forgot context? So when you look at what's in this set of things, and there's some really cool stuff here that sometimes I think we actually don't talk about enough. You look at Cloud Code. This is a great set of tooling that plugs into many of your favorite IDEs. You're using the JetBrains suite, you're using Visual Studio Code, right? A number of cloud editors. You can do some things here to get the kind of plugins that are nice, that make it easy to browse available APIs, look at your instances of GKE, deploy to Cloud Run, pull in snippets into your environments that already have pre-configured YAML, which is great for me because I never get a Kubernetes YAML done right. So how about I pull in a snippet that does it for me? That's amazing. So you'll actually see a demo of some of this. Cloud SDK, I think we've got I don't think, I pretty much know we have the best SDK in the public cloud because we've put a bunch of cool stuff in here. Local emulators. Right? I can emulate pub sub. I can emulate Cloud Run and Kubernetes and all kinds of cool services right on my desktop. I don't have to provision Bigtable in the public cloud. I have an emulator here. So Cloud SDK has all the sort of CLI tooling, a bunch of emulators, a bunch of other things that we package up to make this easy for you. The Cloud Shell is pretty cool. So if you're just not even a Google Cloud customer, you kind of get a free shell in the cloud. And to be able to go there and use a Cloud Shell loaded with all kinds of tools already, really easy to do some deployments, take advantage of our fast network and do some crazy fast download speeds to maybe download a package and deploy it to your workstation somewhere. So some cool stuff in Cloud Shell. And also some great stuff around Cloud Build. This is our serverless CI and CD sort of system that can build and deploy things to VMs or containers, all kinds of fun stuff. This system as well, something you can emulate locally. And then even things like our API gateway, other kind of first-party services that developers can use as they're building services and building microservices. So a cool set of things here that even if you're not doing stuff in Google Cloud, frankly, in many cases, these are very helpful to you, regardless of where you're deploying to. So let's look at two things. We're going to do this throughout each of these sort of roadmap sessions. We'll talk about some of the recent releases, and then we'll talk about what's coming. So we'll give you a sneak peek. Don't tell all your friends, don't tweet about it, but we want to show you what's coming up next. So first, what have we been doing with Cloud Code? So some really good stuff here. Like I like the starter templates. You might be in your organization saying, hey, here's the way we like to bootstrap systems. Here's the sort of configurations. Here's the sort of things that we like that should be part of that deployment package. Cool, you can actually do that with Cloud Code now and say, hey, here's our starter template in a Git repo, and your developer sucks in all that configuration immediately. And this looks like however you want it to look. So that can be pretty powerful. We've also got integration now with Autopilot, and we'll talk a little more about Autopilot shortly, but great way to consume GKE. If you're on the new Macs, you have the ARM client support, and then just continuing to tighten up even Minikube tooling. That keeps getting smaller and smaller in the footprint. If you've been using Minikube for years, it used to be kind of big to download a lot of the images necessary. That keeps getting tighter and tighter and faster and faster. So Kubernetes development has moved from scary to just like somewhat reasonable, which is good, thanks to Minikube. If you look at the Cloud SDK, lots of good stuff. One of my favorite things to do, and maybe I need more hobbies, is actually update my Cloud SDK every week when I get the email, because you see a lot of cool flags get moved from beta to GA. You see a lot of new features get included. Our Spanner emulator went GA. Spanner's awesome. Might be the best database in the cloud. Now you can emulate it on your desktop. Continue to introduce more CLI flags, improving the install support. So tons of things in the Cloud SDK. Keep that one up to date. There's lots of great stuff in there. If you look at the Cloud Shell, again, you can just with a Google account, period. You don't need a Google Cloud account. You can have a free shell in the cloud from us, including a cloud-based editor. And so we bake this thing in. You can actually build applications, compile, deploy, even run on a little local host here in the cloud. So if really you have a kind of a lockdown desktop, this can be a great way to start doing some cloud-based development using our Cloud Shell. And then finally, Cloud Build, which continues to make some nice improvements. If you look at some recent releases, new ways to trigger builds. You can drop stuff into a pub subtopic, and that subscriber can kick off a build. That could be exciting. Webhooks, which could come from your source control repository, some other process, kick that up, even something like workflows. Doing some secrets manager integration, which is powerful, right? If I want to be able to look up values at build time and not embed that anywhere, I want to be able to look up secrets. As well as we'll talk about shortly what's coming up next around even some custom workers and some of the scheduled builds, which is out now. So some good things in here we've just shipped. You should be trying these things out, but let's talk about what's coming next, because this can be exciting as well. When we think about where are we going with this, back to those original things, right? Are we building in best practices? Are we helping your inner loop, right? Helping you use containers. If you look at Cloud Code, a lot of good things we keep working on here, right? Better API samples. This can be tricky sometimes. What's the right way to use these APIs? So baking those in. Making sure you can even compare different environments, because again, we're doing a lot of things now with metadata. So can I compare how one thing looks from the other? Tighter integration with things like our artifact registry, right? Tools like that. So Cloud Code keeps getting better and better. If you're a Visual Studio Code user, a JetBrains IDE user, some really good stuff here as you're working with Google Cloud. I like some of the things coming in Cloud SDK as well. So when you look at how do we continue to do declarative artifact generation, how can I say, hey, here's what this database looks like in a declarative format, so I can actually then just use that over and over again and have an easy way to instantiate that. Going to continue to have consistent client libraries, consistent APIs across different programming languages, which is powerful. So we do a lot of work here as well. There's a lot of languages out there. You all write code and freaking everything. So we're trying to make sure we're supporting you wherever you are, whichever programming language you use, and tightening up that work. Cloud Shell, again, continue to advance that. That's already a pretty mature experience, so just supporting some third-party authentication providers. Cloud Build tomorrow, we're actually going to announce private pools, so keep that to yourself. This is really exciting stuff. So this says, can I actually run Cloud Build in something that has VPC access, in something that's more isolated than just in sort of the shared public build environment? So this opens up the door to a lot of different things. Actually, we're also going to be launching, we've done a private preview, the ability to do hybrid Cloud Build, where I can actually do the builds on premises thanks to Anthos or in different clouds. I'll talk about that shortly. So Cloud Build is starting to stretch to be a way to actually do continuous deployment or continuous integration to a lot of different places, which is pretty powerful. Continuing to offer scheduled builds, which is, I think, available in preview now. So if you want to just run your build every Monday morning at 8 a.m., go for it. And as I mentioned, the hybrid option. So you're seeing more ways to do build, either public cloud, private pools, which are more dedicated, connected to your private assets, or even hybrid, which would let you run the builds wherever you want to, because GKE can be everywhere. So I like what's going on with Cloud Build. This should help you do more and more stuff with one tool chain versus having to use different tool chains in each place. And then Cloud Deploy. So this is a new service that we will be announcing in the coming weeks. This is our first party CD system, continuous delivery system. So what this is making it possible to do is say, once the artifact's generated from Cloud Build, from Jenkins, whatever you use to build an artifact, let's have this system that's now very sophisticated, making it possible to deploy that artifact. And we're going to start by deploying to GKE. We're going to add Cloud Run and other sources after that. But this is a great kind of first party from Google CD tool that then also incorporates some of those DORA metrics, right? Throughput, change failure rate, things like that. So I'm excited to see us kind of get full into a rich CD service. Look out for announcements on this shortly, but you're among the first to know about it. Awesome. So I want to stop here, and we've got Abby here on the line who's going to be doing a dangerous real-time demo, which can always be thrilling. So we're going to look at Cloud Code. We're going to look at what it means to create and deploy some of the apps using that environment. We're going to take like a 30 to 45-second break while everyone stretches and we flip control over this. So get up, jump around, figure out what you can't wait to see from Abby's demo and put it in the comments. I'll see you all in a few moments.
Hey everyone, I'm going to show you how to create and deploy an app to a GKE cluster, all from your IDE with Cloud Code. And I'm also going to sneak in a little bit of debugging in there too. So I'm running this demo in Visual Studio Code today, but as Richard mentioned, we also support JetBrains IDEs like IntelliJ and PyCharm. So I've already installed Cloud Code from the extensions marketplace. And when I do that, I get a bunch of icons over here that align with Google Cloud workflows for Kubernetes, Cloud Run, Cloud APIs, and Secret Manager. And down here, I have this little Cloud Code button. If I click that, I get access to a bunch of commands over here, and I'm going to create a new application with Cloud Code. And I'm going to roll with a Kubernetes application for this demo, but I want to mention that we also support Cloud Run and importing your own custom application from a GitHub repo to use as a base over and over again. So I'm going to select that. And Cloud Code supports 5 languages, and those are Python, Go, Node.js, Java, and .NET. But let's go with a Node.js Hello World. And I'll create this. And right now, Cloud Code's just downloading that sample. And this sample is designed to show you best practices, but also help you get started fast. I'm going to close out this README because we're just going to look at things at a high level. So what do we have here? I have Kubernetes manifests that are all ready to go because I don't like working with YAML, and this gives me a good starting point for my deployment and my service. In my source folder, I have my web application, which is just a hello world sample that says it's running. And I have a Docker file down here. And so if you're not familiar with Docker, we include it for you. But I also want to mention that with Cloud Code, we also support building with build packs, and if you're working with Java, Jib. So I want to deploy this application to my GKE cluster, though. So I'm going to take a look at Cloud Code's Kubernetes Explorer over here. And I've already created a cluster beforehand, and it's called test cluster. But if we go in here, we should have nothing interesting going on because I have not deployed anything to it yet. So I open up deployments, pods, services. There's nothing really going on in here. So let's deploy this. I'm going to click the Cloud Code button, and then I'm going to select Debug on Kubernetes. And this is actually a 2-in-1 action going on here. I'm going to deploy my application to my GKE cluster, but also start a remote debugging session on it to show you all what debugging looks like. So I'm going to click that, and it's going to ask me where I want to run my application, and that's on my test cluster. Yes. And I'm going to open up the Kubernetes Explorer while this is all going on so we can see the magic that's about to happen, hopefully. All right, it's asking me where I want to store my image, and this is my container registry. Looks good. All right, so now Cloud Code is building, pushing, and deploying to my GKE cluster, and we see that things are now in progress over here. My service down here. Pod looks good to go. Now we're just waiting on our deployment. Yeah, the GKE Explorer allows you to just explore all the resources of your cluster. So it's asking where I want to debug, and that my application's in the Hello World folder there. All right, so now I have a port forward URL to my application. But let's try and set a breakpoint real quick to see if we can actually debug this remote GKE application. I'm going to place the breakpoint here, and let's open this up and see if we can trigger it. All right, we are now debugging. So we can view our variables over here. Oh, kind of. Okay, that's kind of stuck. But I can go over here, and we can see my variables updating. Keep on going. Hit play. And over here, here is my application running remotely on my GKE cluster that's been port forwarded, so I can view it here. And I just debugged it. So that's basically my demo. But real quick, I just wanted to show the Kubernetes Explorer a little bit more over here because there's a lot of functionality baked in here, including giving a right click on a pod and getting a terminal right into it. And then I can run commands in here, ls, view all my files in there, right click a pod and describe it, Or for deployments, I could go in here, update my replicas. Maybe I want 3 replicas. And now we see that I have 3 pods. So that was just a quick look at Cloud Code's Kubernetes support, but there's so much more. So I encourage you to give it a download and try it out. And now we'll just hand things back to Richard after this quick break. Short, tiny break.
All right, Abby, that was terrific. I love every time you show that, especially since you didn't really have to mess with Docker files. You didn't have to mess with YAML files. You were able to actually just deploy a Node.js app and debug it and make changes. So I thought that was terrific. So thank you for showing us that. And hopefully that inspires some of you to mess around with this. Of course, not now, because this session is so much fun for you. But maybe after this, you could start trying these things out. So good. So the next section I want to talk to you about is some of the modern application hosts. We've built software. And Abby started to show where we can deploy some of that software too. Now let's talk about some of those hosts. So we're going to dig into that here and look at what are your options here. And again, let's go back to jobs to be done. What are you hiring a host to do? In many cases, you're hiring to say, hey, I want to run the right app on the right service, right? What is the right number of choices? Now, Google Cloud honestly takes a fairly purposely a more narrow approach here. The idea isn't to have 17 ways to run a container here. The goal is to have, hey, there are a handful of the right ways that we think make the most sense. And so you have services like GKE if you want a Kubernetes API, Cloud Run if you're looking for just a straightforward, simple way to run containerized apps. You know, you've got GCE for VMs, you've got functions if you really just want to deploy some quick event-driven code. Like we're trying to have a purposely kind of select enough choice, but not too much. So we want to make sure we're making that easier for you. Secondly, as we think about, you know, a lot of companies I talk to, maybe yourselves, you're thinking about, hey, maybe that first generation app I built that was a little more request response, that was, you know, a little more transactional. Hey, maybe we're moving now to more event driven. We're doing more decoupled systems. We're doing distributed systems. We're doing more reactive processing. So you're looking for a more modern approach. Hey, what services are helping me move into that, at least whatever pace I'd like to move into? And then finally, especially as we talked about earlier, hopefully you're looking at these services, especially for compute, is what's connecting the dots for me. Because sometimes you can have a lot of individual primitive components you have to stitch together from computing and networking and this and that. And potentially you're hiring a good compute platform to do some of that for me and say, look, here's my workload, do magic, like make it available to my customers. So those are things that we think about as we look at our compute runtimes, is what are we doing to make these things better? So what are the choices here? What do you have available to you? So you have GKE. We'll talk about this a little more in depth, but look, GKE is our flagship container runtime. This was the first available Kubernetes managed service back in 2015. Remarkably powerful, the most configurable Kubernetes in the public cloud, the most scalable Kubernetes in the public cloud, the most integrated, the most secure. So we worked really hard to make this the absolute premium option, but also, fun enough, hopefully the most cost-effective option. So rarely do you get both, but that's what we're aiming for here. And at the same time, as you look at other options like functions, hey, I've got a snippet of Go code, .NET code, Python code, and I want it to respond whenever something happens over here. Functions are amazing at that. That's where serverless is terrific, and you can build a lot of systems where your functions are really just the glue code between a bunch of managed services. You have a new architecture. At the same time, you can look at something like Cloud Run and say, hey, I also love this sort of scale to zero. I love this event-driven sort of processing. But I also want like the unit of compute to be a container, because I want to bring my dependencies with me. I want to do more actual full apps with multiple endpoints in my API, not maybe the one at a time I would get with functions. Maybe I have concurrency. I want 100 concurrent connections, which you don't typically do in a functions world. So it's nice to have that option if you want to dip into something more rich. Of course, Google App Engine continues to be a premium kind of original platform as a service model for how do I just take code, run it, get an endpoint, have it just scale behind the scenes. That's terrific. That's available. And then we've recently launched Cloud Workflows, which is a really cool tool for building some of the stateful, long-running connections between some of these more asynchronous operations. If I want to coordinate a bunch of functions, I want to coordinate Cloud Run, these things can run for a year and just kind of connect and do some stateful processing, decision processing between endpoints. So workflows is pretty cool if you haven't tried that out yet. A really nice way to stitch together sometimes things that can feel disconnected. So let's look a little bit at recent releases because we've been doing some really fun stuff in this space. So GKE. So a number of great things. First, I'll start with Autopilot. That's really the flagship thing we've done in the first half of the year. What is Autopilot? Autopilot is us taking GKE, as I mentioned, the most configurable, rich kind of Kubernetes in the public cloud, and taking that and saying, hey, there's a bunch of best practices we've introduced on this around security, around patch management, around scaling. And so up till now, you have plenty of options for how you tune them. And that's powerful. But sometimes you're going to come to us, and many of you have, and said, I like Kubernetes, I like the API, I don't really want to run it. And even GKE standard, as we call it now, still requires you to understand, when to scale nodes. You have to understand some troubleshooting. Autopilot says, I just want the Kubernetes API. Google runs everything underneath. We provision the nodes, we scale it, we manage it, we patch it, all of those things. All you do is deploy to it, and it swells to whatever size you need, can contract if you don't need it. Almost feels like a serverless Kubernetes. Still GKE, no weird magic beneath the covers. Right? You can still just GKE. We've just put all of the automations on by default. We've done our best practices, and Google site reliability engineers run it for you. So really, really cool way, and you just pay per pod. So really nice way to get the Kubernetes API and the Kubernetes ecosystem without having to get all the Kubernetes operational skill. We've also continued to introduce more scaling knobs that you can turn, things like multi-dimensional pod scaling, scale up and out at the same time with different policies, which can be powerful. Multi-cluster services is cool. So if I have 2 clusters, and look, a lot of you are starting to scale out versus just giant Mongo clusters of just tons of pods. You're saying, hey, I'd like to distribute my clusters across regions. Maybe each app gets their own cluster, however you want to do it. But then that brings new problems, of course. And so one of those can be, hey, things between clusters are kind of invisible to each other. How do they see each other? So multi-cluster services is a free service that makes it possible for services in different clusters to do service discovery. And I can see and address services across clusters without having to necessarily add a service mesh or things like that. It's a very lightweight function, but it's free and easy to use. We've continued to add more Windows support, and Windows consumption in GKE is spiking right now. It's great as people are realizing this might be a better way to run Windows in Kubernetes and a better way to run it in GKE. So a lot of support there, including workload identity, which actually lets your pods assume an identity in the cluster and then talk to first-party cloud services using that identity. So it maps a pod identity to an IAM account, which can be great for a more secure structure. So lots of great things happening in GKE right now, really aggressive stuff we'll talk in the future, but even the recent releases are awesome. Cloud Functions is doing some great stuff. So we're adding new runtimes. You can bring in all types of platforms now from .NET and Ruby, all kinds of great things, new regions, shared VPC access for accessing things in your VPC, making sure you have access and control for controlling things like HTTPS. So Cloud Functions continues to get richer and richer as well, which is terrific. App Engine keeps scaling to more regions, adding more runtimes. Again, this is a massively used service, tons of customers who take advantage of this, and we continue to make this rock solid. And Cloud Run continues to get a lot of great improvements. So now you might look at it as, well, this is just great for some web traffic. But we continue to make this even better with gRPC, WebSockets, HTTP2 support. And so you can have a lot of ways to invoke Cloud Run. So if you just have a containerized app and you just want it to kind of sit out there and run, and it can scale to 0 and respond to events, Cloud Run's amazing, right? You're just paying for requests. It's a super easy to use service for a lot of developers. We've now expanded this to every cloud region. You can have minimum instances. So if you were worried about functions because sometimes there's a cold start challenge, if your application has a little bit of a warm-up process, you can even define minimum instances in Cloud Run and say, hey, you're always going to have 2 running, 1 running. And when that 1 is running and not doing anything, we charge you 1/10 of the price. So even if you have a minimum instance, we make sure you pay less while that's running. And you have shared VPC access. So over time, I think GKE Cloud Run, you're going to find you're using both of those a ton, which is terrific. And then workflows, we did go generally available with workflows. We added a bunch of new connectors. This makes it really easy in a workflow to talk to different Google Cloud services. Things like PubSub, Firestore, Secrets Manager. We're shipping more and more connectors as well. So We've been shipping these updating workflows. It's a pretty, again, kind of a fun system to use, pretty easy to use from the console. So again, give this one a spin. It's a nice way to connect the dots between a lot of different functions and services. So what's coming next year? So again, is how are we supporting folks in all of these platforms? Well, with GKE, we're working on things like predictive auto-scaling. How can we not even just do it based on a schedule or this or that, but we anticipate something coming using machine learning and AI? How do we do things like hot standby node pool so that when scaling does happen, you have a pool kind of ready to take that load and you don't have to wait while new infrastructure comes online? And we've recently actually released multi-instance GPUs. This is the ability to take a GPU and instead of allocating a whole GPU when just one pod needs it, you can actually have kind of slice up a GPU into 7 different instances and different pods can use the same GPU. So more cost effective, easier to use ML capabilities within your app. So again, trying to make this very, very cost effective, super scalable, super configurable, plus autopilot keeps getting better, better every month. With functions, we're adding EventArc triggering. EventArc is that subsystem in Google Cloud we released last year that actually really mostly is looking at logs and then triggering things in things like cloud functions. So maybe every time a new invoice hits cloud storage, you should trigger a function. Every time something hits pub sub, every time a new log is entered, every time somebody creates a new BigQuery table, right? These are all things now that you can just say, I want to do something when that happens. And EventArc stitches that together for you. So we're adding that support to cloud functions. .NET support we've actually just recently added. We're going to add that minimum instance count to cloud functions as well. So if you're worried about cold starts, we're going to get rid of that for you. And even bring in things like cloud secrets. So again, you can have secure code, things that you can pull in at runtime. App Engine, again, continuing to add more runtime support, private IPs, things like that. And Cloud Run is getting a number of security features. So we have introduced binary authorization. This is a functionality that used to be just part of Anthos, and we've extended that. More or less, this lets you control some things before something gets deployed. And you can have a binary authorization that says you can't deploy to Cloud Run unless it meets these criteria. Maybe only if it came from this particular source code repo or got built by this build system or things like that. So it gives you kind of a gate in front of your runtime that you can configure. Likewise, integration now with Secrets Manager. You can bring customer managed encryption keys, bigger scale. We continue to introduce more and more. Even just this last week, yesterday, I think, or 2 days ago, we introduced new ability for concurrency. So up to 1,000 concurrent connections for a Cloud Run instance, which can be amazing if your code is very reactive, very event-driven. All of a sudden, you don't have to have maybe 1,000 functions spin up. You could really have one Cloud Run instance handling 1,000 requests. From a cost perspective, that could be pretty compelling. So Cloud Run, again, continues to get better and better. And then workflows, continuing to ship more connectors, actually adding, I'm excited about this, HTTP callbacks, meaning you might send something out of a workflow and then be able to sit there and wait for a response to come back related to that, and then be able to continue your flow. Adding more parallel processing for different steps in your workflow, and as well connecting back to EventArc. So EventArc kind of forming a good subsystem within Google Cloud, you can tell that, as well as some of these core functionalities we keep bringing to a lot of these runtimes. So honestly, in many cases, you can choose your runtime and swap them over time. You might start in GCE and move to Cloud Run and move to GKE and float around. And though in many cases, your identity story, your monitoring story, your logging story, these things are going to stay the same, which is awesome. So you never have to feel like you're just investing solely in one stack. Really, the Google Cloud Platform moves between most of these runtimes. Cool. So my last section before I hand off and you get to chat with somebody else is looking at some of the hybrid and multi-cloud work. What have we been doing in this space to take some of these development tools, runtimes, practices, and made that available elsewhere? We're still fairly unique in how we're approaching this, and I'll talk a little bit about what we're doing and where we're going. So what's the point? Why are you buying a hybrid or multi-cloud thing, especially from Google? So first off, you're doing it because you have a fleet challenge. And whether that fleet is in only Google Cloud, whether that fleet is on premises, whether that fleet is spanning clouds, increasingly we're seeing people run more distributed infrastructure. You're putting clusters in different places for different reasons. There's geography reasons and kind of latency purposes. There's feature functionality for reasons you're in different clouds. All of those are fine. But as you now have that, then you have a consistency challenge. How do I make these things look consistent? How do I apply consistent policy? How do I not triple my operational burden? And so typically you're hiring platforms to help you in this world to help you manage a fleet. and not increase your operational burden. But then you're also looking to hire these sort of platforms to help with the dev experience in the cloud. Can there be a consistent dev target? I just don't think most developers need to learn 90 ways to deploy stuff based on which cloud they're going to. Like, these are somewhat solved problems. Can we make this easier for you by giving you a great deployment target on any cloud? Here's the same GKE running on Amazon, running on Azure, running on bare metal, running on vSphere, running on Google Cloud, and go at it and have fun. So unifying that dev experience. And then finally, modernizing things. This is not just for the new app you're starting today. You're not just following Abby's guide and saying, new app, okay, now I'm ready for cloud. I want to take what you have in WebSphere. I want to take your existing .NET Framework app. Like, these are great. These are super valuable systems. Let's put them on a better home. So what are we doing? Can you hire systems like this to help you modernize your existing apps and infrastructure? This will even come up as we talk about the Apogee discussion, other ways that we are helping you bring what you have and modernize what you have. So what makes this portfolio up? So really, it's a mix of Anthos technologies. There's Anthos itself and GKE clusters. There's the service mesh, the config management system, as well as the migration tooling, which is actually pretty exciting stuff. So if we look at what this is, it's really helping you run fleets, whether you're only in Google Cloud and trying to run a whole fleet of clusters across regions, or whether you start stretching hybrid on-prem or multi-cloud. All of these are meant to address that. So what have we been doing here? So Anthos has been getting, especially GKE clusters, getting a ton of great stuff here. So we've added bare metal support. So you can run Anthos GKE clusters on just a bring your own OS environment. And actually in the last release, we actually just added support for super small edge footprints. So you could actually run a GKE cluster on 2 vCPU, 4 gig of RAM at a retail edge, in a closet in the back of an oil rig. You can do it all kinds of different places. So we're trying to make sure we're letting you bring GKE clusters to wherever you'd like. If you're a Cloud Foundry customer and wondering about that roadmap and trying to move to maybe something a little more second generation, we've actually supported now, released the KF tool. KF makes an Anthos cluster look like a Cloud Foundry cluster, same API. So now your developers can use the same sort of Cloud Foundry tooling, but now they can run on GKE and Istio and all these sort of modern technologies. So that's great for them. We've added Windows container support, so that's available on premises now. Workload identity, so you can bring the same identity strategy from GKE to Amazon, to Azure, to on-premises, which is terrific. We introduced a new Connect gateway, so once you attach a cluster to the Anthos control plane, you can reach it from Google Cloud. I don't care if it's on your desktop. It doesn't matter if it's buried behind a VPC in another cloud. We're actually opening up a secure connection between your cluster and the public cloud so that you could send deployment directives to a cluster at the edge. You could do some operational checks. You could do a number of things. So this opens up, again, an at-scale capability that's pretty awesome. As well as we've added more attached cluster types. Attach a kind cluster from your desktop. Attach Rancher clusters, OpenShift clusters, and more, AKS, EKS. And we certify them. So this isn't just best effort. We're actually testing this and certifying which ones we support. So if you're looking to run GKE anywhere, Anthos is a great choice for that. And we've actually continued to add more and more so it supports more workloads. Now, a key part of Anthos is the service mesh. This is an Istio-based mesh that we've enhanced with additional things like a managed certificate authority, some observability where we're actually taking some of that telemetry and helping you visualize that. Right, a number of cool things that we've introduced into that. Well, we've also added support for virtual machines in GCE, making it easier for a managed control plane, which we've introduced. So if you like the idea of Istio, but you don't really want to run Istio, awesome. Now you can do managed control plane in Google Cloud. So if you're a GKE customer saying, I think Istio might be the right move, but I don't feel like running this, today you can deploy now the managed control plane, which we actually then run the Istio layer. We scale it, we secure it, we provision it, and all you have is your sidecars. And we're launching a new data plane managed as well. So we're going to take more and more kind of control of this to make sure you don't have to. So that'll be great. So that's available today for you to try out. And as well, we've also launched a standalone version of Anthos Service Mesh. So if you want to use Anthos Service Mesh just on GKE on Google Cloud, terrific. You can pay per use and just use that. You don't have to use the rest of the Anthos services. You could just say, I love the service mesh idea. And we have a number of customers moving from original, just self-managed Istio to this to light up some of that new functionality and offload some of the ops. Same with config management. Some pretty powerful stuff. So when you think of fleet management, the hard part can be, how do I manage the inside of the cluster, the namespace shape, the policies, the sort of what gets deployed? How do I bootstrap 100 clusters so they actually look the same? And so Anthos config management has a number of subsystems, including config sync, which takes a bunch of Git stored configurations, applies them to a number of clusters, 1, 1,000, 10,000, whatever. Also a policy controller based on the Gatekeeper project, as well as a config connector, which actually lets you provision and manage Google Cloud services as if they were Kubernetes resources. Powerful stuff. So we've added more functionality for this, for hierarchy of different repos. We've made it easier to do things with the config connector. Now 60 plus Google Cloud services you could actually provision with a half dozen lines of YAML, which is pretty awesome. So create your Redis service, your memory store Redis instance, create a pub sub subscription, a big query table, all kinds of fun things that you can do with the config connector. And then with Migrate for Anthos, again, and Migrate for Anthos and GKE, it's actually a free service if you're a GKE user. And even just it's included as part of Anthos. What does this do? It takes a virtual machine-based workload, and this tool will introspect that, pull out the application, leave the VM behind, system files, OS files, services, all that stuff. Take the app and turn it into a container that now you can run on an Anthos cluster, GKE cluster anywhere. This is an awesome way to take Windows or Linux applications, stateful or stateless applications, commercial or custom, get them out of the virtual machines into a container image, and get them where they can run somewhere else. And that doesn't modernize the app per se, right? You're not changing the code, but you are making it now available to run on a more modern host. You're offloading OS management, because now those Linux ones run on our containerized optimized OS. So you're out of the OS management business. You've run it on a modern platform, and it's really easy to use for both, again, GKE or Anthos environments. So we've added some discovery tooling to this to actually help it introspect applications. We're going to support more than just our artifact registry, and you can actually run this on AWS and other places. So making it really easy to pull VMs from vSphere, from AWS, from Azure, from Google Cloud, pull those into container images. Some cool stuff. If we look at where we're going next, with Anthos itself, so we're now in preview, public preview for Azure. And this is, I'm actually excited about this one, is this is a new architecture for us. Meaning, Anthos on AWS today is cool stuff. I use it a lot. But the way it starts is this sort of inception thing, where first you create a management cluster, and then you hand configurations, YAML definitions to that management cluster, and then it spins up a user cluster. It's a common pattern. You see it in a lot of platforms. But what we've done now with the Azure support, we're backporting to Amazon, is we said, how about we are the management service? How about you just go to Google Cloud and say, give me a cluster in Amazon, give me a cluster, a GKE cluster in Azure, and we'll be the management service, and all you have running in that other cloud is your user cluster. Now you're not operating, securing, scaling, provisioning management services anymore. We're the management service for you. So I'm excited about that. That simply means that now you can use Google Cloud to provision services all over the place, in the future on premises as well, and really have Google Cloud as the one control plane wherever your clusters happen to run. We're also making sure we're adding, over time, we're going to be adding some virtual machine support, so stay tuned for that. So how does Anthos manage VMs? How do we support more first-party services for data, for things like that we're working on as well? And then continue to simplify and even shrink some of the install footprint. So tons of things coming from both a GKE perspective, VM-based management, first-party service management. This is really a hub for us for how we help you manage infrastructure and services anywhere you'd like to be. On the service mesh, we're going to keep trying to bring the VM support we're doing in Google Compute Engine today, bring that on-prem, introduce more of the common dashboard experience, even if you're on premises. We are looking at adding Anthos Service Mesh to Cloud Run as well. And then simply standardizing the support across all the attached clusters and places like that. The config management, we'll announce this here in a couple of weeks, maybe even a week or so, is the ability to use Anthos config management standalone as well. So if you say, look, I really like this sort of fleet management. I have a lot of GKE clusters. I'd really like to apply consistent configuration. I like this gatekeeper stuff and being able to apply policies to namespaces and pods and all of that, but I don't need the rest of it. Cool. Go ahead and just buy Anthos config management, pay for that. It's more of a managed service, still get the same benefit on Google Cloud. And then if you like it and you want to bring that off-prem too, cool. Then you can bring it off-prem as part of Anthos as well. So again, you're seeing our service mesh or config system. We actually just enabled multi-cluster ingress as well as a standalone service. So if you have multiple clusters and one virtual IP that feeds all of them, that's now a standalone managed service versus only being through an Anthos subscription. So again, great stuff here, whether you're using it in Google Cloud or off platform. And then finally, if you look at Migrate for Anthos, We're supporting, again, more types of in-place migrations, whether you're in vSphere or Amazon. We're GAing the Windows container support, and we're doing some more and more around WebSphere workloads, JEE workloads, .NET workloads, to try to make sure that that's an easy migration. We want to help you build a migration factory to these platforms so you can start to turn off some of those older systems that are hard to maintain. All right, I fired a bunch at you. Hopefully that was mildly entertaining. There's a lot of good stuff as we look at the dev tools, we look at the run times, we look at the hybrid story. Through all of it, we're trying to make sure you're doing some smart defaults, that we're trying to introduce cool cloud innovations, but also just kind of meet you where you are. The goal isn't to be years ahead. If anything, you're helping us find the right place to be. So we're trying to introduce the right tools to help you today, but hopefully take you a little further. So we're going to take a short break here before we come back with some additional things. Thank you.
Great. Hi, welcome back, everyone. My name is Tyler, and I'm a customer engineer in the Apogee API management team. And so today I wanted to show you some new updates that we've brought in the world of APIs to Google Cloud and all the cool features that are coming down the road next. So let's dive into it. Some of you might be wondering, hey, how do APIs and API management fit into all the other cool, service mesh and Anthos and Kubernetes topics that we have been hearing, so much about in Google Cloud? And actually, they fit together really well. As you can see in this picture, on top of the Anthos service mesh and Kubernetes and Cloud Run and Knative and all the ways to run our code, it's often a question of how do we safely and securely and in a scalable way offer those APIs to both internal and external consumers, right? So it could be that we're managing hundreds or thousands of services in our service mesh, and the aspiration is that all services are managed within a service mesh. And with Apogee, we're typically managing hundreds of curated, documented, versioned APIs that we're offering to our ecosystem partners. And the aspiration there is that all shared APIs are managed in a consistent way in an organization. So with that, we kind of fit on top, of all the infrastructure and developer tooling that we've been seeing, so much about in this session. So that means on top of Google Kubernetes Engine and Anthos Service Mesh, typically run by infrastructure operators and SREs. We have developers pushing their code to Cloud Run and directly to Kubernetes. And then we have, Apogee and API management sitting on top, where the API product owner and developers work together to publish those APIs in a secure and scalable and documented way for maximum reuse and digital channel consumption to partners and ecosystems and anyone who needs, who wants to use your functionality in your APIs. So the latest release that we just released a few months ago actually, is Apogee X in the Google Cloud, which is a new release of Google Cloud's API management platform with enhanced security, an integrated approach to web application firewall and identity management, so deep integration into Google Cloud platform tooling, more scale and performance of the APIs, so using the power of Google's global private network to make the APIs more reachable and globally available where your users are. And enhanced automation for the operations and detection of threats and unregular consumption of your APIs. So altogether, this is a really interesting way to further scale and promote and offer your services and your functionalities for consumption. Another really cool feature in Apogee is the possibility to easily debug distributed APIs. So no matter where your APIs are located, they could be in the Google Cloud, in Apogee X, they could be running in Anthos or in any Kubernetes environment in lots of different locations. We can connect and remotely debug those APIs and actually step through the processing to see exactly how that API traffic is processing, is securing, is authenticating, is connecting to our backend services and to our public consumers. This is also really, really helpful in case something goes wrong, but also just in our normal development, dev, test, delivery cycles to get a clear picture of how API traffic and consumption is being handled and processed through our API layer. The next big innovation that we've recently been updating and delivering is support for API monitoring deeply into Google Cloud. So we all know that one of the coolest services in Google Cloud is Google Cloud Monitor, right? So seeing near real-time metrics of exactly how our code is processing requests, all of our business logic, pushing metrics and performance and latency information into Google Cloud Monitor. And now we have all of the API data right there along with all the other monitoring metrics. So we can really build rich dashboards that show, end to end from consumers, from the app and application API layer down to our code and services and connection to other applications that are also feeding their data into Google Cloud Monitor to have really an end-to-end consistent visibility of all the connectivity, latency, performance, fault, error information. So basically really all information to track it in real time and be able to have alerting and notifications based on any events in that data. We also released an update recently to support Cloud Trace for distributed tracing, but I'll get more to that in a moment. This is also connected, of course, to audit logging and, like I was saying, to tracing, so that all of those metrics around exactly the flows of the processing. So, which methods, which operations, which headers, which data are being pushed through the different layers of our applications. That we see that in real time in Google Cloud Tracing. Audit logging, on the other hand, is to make sure that all the operations that are done at the platform level, right? So granting access, deploying new versions of APIs or any code, making changes to the platform, that's all visible in audit logging. And so we see that information from Apogee as well as all other Google Cloud services. Also a new release, part of a package we call Advanced API Monitoring and Security is called Anomaly Detection, where basically we apply AI and ML technologies to the historical time series API data. So of all the consumption data, or you can also define a subset of that data to use for the modeling purposes. And then to detect and alert automatically any anomalies that are starting to pop up in that data. So, if all of a sudden latencies are starting to increase to certain backend services, or a higher rate of errors are detected for some backend services, or other faults are popping up, we will detect, first of all, that there are anomalies popping up in the API traffic, and then we can also define thresholds to fire alerts based on those changes. And this is really powerful because, normally, when bad things happen, of course, we find out about it and then we configure the alerts later, right? To make sure it doesn't happen again as part of the, root cause analysis, and make sure lessons learned and all of that. The cool thing here is that we want to proactively alert you so that before the actual bad things happen, when the first signals start coming, that something might be developing or might be coming in the future, that we can alert you even earlier to maybe even be able to prevent those original occurrences, and just make our software even more stable, even more robust, even more fault tolerant, and correct for issues as early as possible. So this is a really exciting development. It's available today to test in any version of Apogee, also the evaluation version that you can provision in Google Cloud, so you can immediately deploy this and start playing with it. And as a last thing, I think it's important to see, with Apogee and APIs kind of as a layer on top of all of the other infrastructure and application development and services in Google Cloud, that we have a lot of flexible deployment options for deploying Apogee X and API management. So it starts with the GCP managed version. So we call this Apogee SaaS, which is completely managed in the Google Cloud. So the control planes, all the management and analytics, as well as the proxy runtime plane in a private Kubernetes cluster, are completely automatically managed for you in the Google Cloud. And you can try this out today for free, provision evaluation instances and test it for 60 days for free and see exactly how that can work with your services. In Apogee Hybrid, on the other hand, we split up the control plane. It's the exact same control plane. And then the runtime plane can be deployed in any customer managed environment that runs Anthos, right? So this can be everything from GKE, AWS container services, Azure Kubernetes Engine, bare metal, VMware. So everywhere that Anthos runs, we can deploy Apogee Hybrid, which of course really makes it easy to push out APIs to any location where either consumers or backend services are located, right? Just to reduce those round trip times, reduce latencies, and make sure that APIs are responding in the shortest amount of time possible, using caching and all kinds of policies to make basically real-time decisions and real-time APIs available to your customers, your partners, your users. The last option that we also recently released in version 2.0 is the Envoy adapter for Apogee. And the Envoy adapter is at the bottom, and it sits basically completely customer managed. You can deploy the Envoy adapter using the open source Envoy proxy host in any environment where Envoy runs. So this can be as a sidecar in Anthos Service Mesh. This can be in standalone, VM gateways. So basically the possibilities are endless. And the cool thing is that this is a lightweight proxy that gets the configuration from the Apogee control plane and feeds the analytics data as well back to the analytics plane. So basically you can just expand your API landscape and your footprint really, really easily in a lightweight and scalable way. So this is a great option for embedded IoT use cases, edge use cases, anywhere where maybe a full Kubernetes cluster might be too much infrastructure and where we just need a lightweight proxy that we can deploy but still have the API management features available. Great, so with that, I would like to jump over to a demo and show kind of some real world use cases, how this looks in production, and also show some of these services, how exactly they can be used in your use cases or with your code. So you should be seeing my screen now, including a GitLab repository where I have some microservice code here, a Kubernetes deployment, as well as my API proxies, my Apogee definitions, and my Open API specifications. In this case, it's an SAP API application. So we'll be proxying and connecting to some SAP backend data and displaying that in a web dashboard. And this is kind of a best practice to have our proxies in the same repository as our source code, our deployment manifests, our Open API specifications, and we can all deploy this in a completely automated way and test it using Cloud Build, for example, into our Apigee instances and Kubernetes deployments. So the web app is actually running here in Apigee. And this is a dashboard for my sales orders in SAP. And it's connecting to an API in Apigee as well, and delivering and giving me my sales order data in real time, as well as enriching it with some location data for my orders to be able to view those on a map here in a Google Maps widget. The proxies for this are running here in my Apigee hybrid instance. So you can see this very clearly marked here as hybrid. I can also switch to any other Apigee instance here in the dropdown in the Apigee console. So including all of my Envoy adapters, my Apigee SaaS versions, as well as all my hybrid deployments managed and visible in the same control plane, in the same analytics. I also have an overview of all of my microservice proxies that are deployed in the cluster, in the hybrid environment. So including the dashboard service for my front-end UI, a broadcast service that is responsible for broadcasting updates in real time so that I can see any new orders that come in right away. A location service, an order service. So basically all of the data that my front end and my app needs, or any other apps that want to work with this data, are contacting these APIs directly. The services then, and Apigee is running then in a Google Kubernetes Engine cluster over here. And this is just a standard GKE deployment. We have in our default namespace, my microservices are deployed, as well as then Istio system and the service mesh for the Istio ingress gateway and ASM functionality. And then in the Apigee namespace, the Apigee deployment, including data caching, metrics, collectors, synchronizers. So basically everything needed to pull down the Apigee, the API config data, offer that as APIs in the cluster or through the ingress, and then collect and push up the metrics and analytics back up to the cloud. So I mentioned also the new features around anomaly detection. And so I can see this in real time here back in my Apigee console that, I can see then in, here any events that are developing that are just anomalies, right? That are popping up as new patterns in the data that potentially should be investigated, or that could signify, some developing issues that could further develop and get worse and worse. So these can be things, for example, increased errors, faults are popping up, so that certain steps in my API processing, like converting JSON to XML, something's missing, and so we're getting errors occasionally. And these can also be increased latencies, right? So that backends are suddenly reacting much slower than normal, or so issues like that are popping up. So when I look at my list of events that are coming, and I can also filter by time range, and then also get alerts to these events as well, and then drill down to see exactly what kind of data was detected. And so, for example, when errors start occurring, then we're going to see an increased error rate here. If this is latencies, then we would see the increased latency rate, and we can see exactly how this anomaly is detecting over time, is developing over time. You can see that normally we have about 250 errors per or 20 minutes or so, but suddenly this is rapidly increasing, and so this is something that really should be looked into. We also see exactly what the status code and the locations of who's reporting this, and then we can actually drill down even deeper when we click on here and see, okay, exactly which proxy is this, what's the status code of 500, for example, and then we can also switch over to Google Cloud Monitor to see more information about this data, or configure alerts that can then in the future alert us more proactively. Another cool feature that I mentioned is the real-time tracing also. So Apigee supports the open telemetry format for tracing data, so that along with having all of that monitoring data and alerting and anomaly detection in Google Cloud Monitor, we also have complete tracing data available as well, so that when I deploy those APIs to any Apogee hybrid instance or to an Envoy adapter somewhere, I also get this tracing data fed back into my tracing framework of choice, which can be supported through the Jaeger interface to other tracing systems, as well as to Google Cloud Trace by default out of the box. And so then I can have this very detailed reporting around exactly what kind of calls are being made to my APIs, and exactly the processing being done to those API calls. So in this case, in my original web app, we're showing orders in the order service, and this call takes around 500 milliseconds, contacting SAP in the backend to retrieve those orders. And we also see exactly the processing of that data through our Apogee runtime. So it took us 480 milliseconds to get that data from the backend. Then we started processing it. We had some JavaScript code to convert it into JSON from OData, and doing some other things, and then sending that back to the client. The cool thing is that if I have further microservices that are doing some processing, either for example, before I get to SAP, or some microservices that are offering some additional functionality, and they also feed their data into Google Cloud Trace, then I will see these end-to-end tracing, and I can also track exactly the performance of basically every step of functions in my own microservice code, as well as processing in my API management framework. And so really see that processing end-to-end, and track down performance and exceptions and any other tracing data that pops up here. Great. So I hope that was interesting. It kind of shows behind the scenes how we can provide an innovative web app, consuming data and APIs from all kinds of systems, from SAP to microservices, all running in our Kubernetes framework for the microservices and APIs, and then connecting from there to further backend systems, and really pushing innovative, monitored, secured, traceable APIs all to any location, basically using an API solution like Apogee in the Google Cloud. Great. So with that, I would turn it back over to our programming, and thank you for your time, and look forward to the next sessions.
Okay, hi everyone. My name is Patrick Fauché. I'm a senior product manager working on artifact management and software supply chain security. here at Google. So I'm going to jump right in. So as modern software development practices have evolved over the last few years, there's been a heavy reliance on distributed environments, distributed teams, as well as a great deal of open source software that permeates throughout many software supply chains across the industry. And given that, there's two critical areas that have emerged within the practice of software development and delivery. And they are artifact management and security. So you'll see here what we're focused on is enabling companies to use fully managed cloud repositories with whatever CI/CD toolchain they have. And then we offer ways for them to further streamline CI/CD processes when those repositories are used with our own tools, such as Cloud Build, GKE, GCE, and Cloud Run, which I'll demonstrate later on. So we're developing a suite of tools that enable the software teams and the system operators to more efficiently manage those images, those packages, software OS packages and language packages, and other important artifacts, along with metadata that describe and secure those artifacts, all at scale across multiple teams and regions globally. But perhaps more importantly, a topic that's become very heated in the industry is providing verifiably secure software pipelines. So what we're trying to do here is integrate a bunch of best practices along with capabilities that we already have. And as we evolve more capabilities for security, all to enable teams to establish trust within that supply chain, starting with source packages to certified base images, all the way through to how things get built and deployed to production. And again, I'm going to dig into this a little bit more after I walk through our roadmap. So recently we released Artifact Registry to GA, and that's the centerpiece of our platform for securely managing software artifacts across the enterprise. In addition to on-push vulnerability scanning, we've added on-demand scanning capabilities that allow teams to detect vulnerabilities early in the build test lifecycle. We've added support for various language package repositories, and we've enabled teams to optimize performance and cost by allowing them to regionalize their repositories across most of our major regions. In fact, I think we have all the major regions covered today. In terms of what's upcoming, we're focusing on integrating some of the best practices around software security that I mentioned for securing the supply chain. We want to make that process more manageable and more achievable for enterprises with features like verified builds, deep scanning of language packages that show a dependency tree and impact analysis of all the upstream dependencies, automating the process for maintaining a certified, secure base image library that teams will use for build and deploy. And then another important capability that we get asked for quite a bit is the ability to create proxy repos that can support different caching schemes so that teams can secure those artifacts and packages that are coming from publicly available sources, such as Docker Hub, for example, and ensure that those application teams are not impacted when suppliers like Docker Hub have an outage or change their SLAs, which has happened recently. So now teams can kind of create a cached version, and then they can build policy and mirroring scheme and rules around that and support distribution schemes in a bunch of different scenarios. So I don't have a deep dive demo today, but just kind of wanted to touch on this whole notion of software supply chain security and attack vectors. There's been a lot that's gone on recently in recent attacks such as SolarWinds, Kodakov, and even more recently, Kaseya. These are all clear evidence that software supply chains represent a pretty significant attack vector for hackers. And not to scare anyone, but this just at a high level illustrates all of the opportunities that exist in your typical SDLC pipeline. And it shows that there are multiple areas where malicious actors can infiltrate and introduce malicious code and packages into the supply chain, and then those malicious packages get distributed quite widely to either your customers or your customers' customers. So definitely an area of concern. And then, more recently, there was the executive order from the Biden administration, basically laying out a timeline for establishing standards and having compliance requirements for any company that's doing business with the government, as well as any company that's providing critical infrastructure. So they have to validate that their software development lifecycle process is secure. So this brings a lot of questions. How do companies best protect themselves from attacks? What tools are needed? What are the best practices? What standards are there for these types of processes? And more importantly, as a business, how do you do this without slowing down your development process, which is critical to your business? So what I'm going to illustrate here is the core concept for software supply chain security, which is to build a chain of trust, starting from source and following all the way through to when your software gets shipped to production, and then continually kind of within these interlocking cycles of, dev, test, build, and then of course deploy and run. Those are kind of concentric cycles within the SDLC. What we're trying to do here is provide means for teams to be able to verify what goes into the build, have some attestations to that effect, have that follow through to deploy time, enable the teams to enforce a policy, check against policy that all required attestations exist before the application runs into production. And then once in production, provide continuous scanning that can ensure that the teams know as soon as possible whenever there's a new vulnerability that occurs in the wild and what the impact is for the running applications. All right, so how do we actually help teams do that at Google? This diagram shows how you can use GCP tools today to implement each of these security processes in your application pipeline. It's as a solution. So it starts with using Cloud Build and Artifact Registry to maintain secure software packages and base images, using our container metadata service to store attestations at various stages that essentially provide some affidavit, some proof of origin on what's going into your containers and all your built packages. And then using binary authorization at deploy time to check a policy of no CVEs at a certain level, or make sure that these attestations exist, or make sure it only came from this build system, to ensure that we know exactly what's gone into the build, who's touched it, what processes, what systems have actually done the build. And if there's an issue, we can trace back to see where that problem started. And then, although it's not illustrated here, we do have a new feature called Runtime Protect, which in certain runtimes like GKE and then soon Cloud Run, you'll be able to actually turn this on and have continual monitoring and threat analysis on all of your running applications, your running images. So it'll know if there's a new incident in the market, with some public package or one of its dependencies even, it's going to know that if you're impacted, how impacted you are in your production environment, which is obviously of chief concern for teams. Hey, tell me when I got an issue in production, obviously as soon as possible, and help me decide what I need to do about it. But what we're also trying to do is get teams to shift that whole practice as far left as possible. Because if you can just prevent bad things from getting in at the start, it goes a long way to ensuring that what's running in production is going to be secure. So at Google, we're really focused on delivering a platform that enables companies to build and maintain trust across the SDLC, from source code to production runtimes. We're integrating features across our tool set that enable these best practices to happen in an orchestrated fashion. So everything from secure artifact management, which is our area, to continuous scan and threat analysis, metadata and attestations, build integrity and provenance, using policy enforced authorization, and of course, workflow automation all the way across. So these are our driving principles, and that we're working towards across a variety of tools, starting with all the secure artifact management pieces and the build pieces in our CI/CD tooling. And we're going to continue to mature and evolve these features as a solution that companies can come in and essentially say, look, I need to be at security level X per my requirements, whether those are internal operational requirements or they're externally imposed due to government regulations or just best practices in general. I don't want to end up as a bad PR story. We're looking to actually integrate these practices into a variety of our services and then have workflows that can integrate these processes from source to prod and make it far easier and more straightforward for teams to be able to say, we need to be at this security level. Let's implement this solution here because it says you'll be at security level X. And that's where we're headed. So I wanted to kind of give a heads up on that. Not a lot of updates since our last roadmap session, but a lot of work going on, and stay tuned for the fall where you'll hear a lot more about our security features and solutions. Thank you.
Thank you for the opportunity to present the Modern Operations Roadmap. My name is Rakesh Thupar, and I'm a product manager in Google Cloud focused on cloud operations. So in this section, I will focus on three things. I will start with a quick summary of what is cloud operations. I will secondly talk about the capabilities that we have released recently. And then finally, I will talk about our product roadmap. So let's get started. So Google offers the Cloud Operations Suite for observability. With cloud operations, you can observe your infrastructure and applications running in GCP, running on-prem, or running in other clouds. Now, but for this session, I will focus mostly on observability of apps deployed on Kubernetes and GKE. So first, cloud operations offers complete visibility on day zero of your entire GKE environment. When you provision your GKE clusters, system metrics and logs automatically start flowing into cloud operations. No agent installation is required at all. By tightly integrating this observability data with GKE and GCE resource pages, and by providing rich out-of-the-box dashboards that aggregate logs, metrics, and Kubernetes events in one place, we enable effective operations and faster MTTR. Users do not need to navigate to multiple services and can easily correlate the different signals because they're all available in one place. Lastly, using service monitoring capability in cloud operations, users can implement SRE principles. This enables Kubernetes developers to achieve high velocity of releases without compromising service reliability. So let us first take a brief look at the different capabilities available in cloud operations. The Cloud Operations Suite consists of 3 key services: Cloud Logging, Cloud Monitoring, and Cloud Trace. Very simply, Cloud Monitoring helps users capture and analyze system and application metrics from a variety of resources, including GCP infrastructure, GCP applications, applications running on other clouds, and from on-premise sources. It also enables users to define and monitor service level objectives and error budgets. Cloud Logging offers users the ability to aggregate system and application logs and explore them with an intuitive Log Explorer UI. We can collect logs from Google services, other cloud services, and from your applications and services running on premises. Cloud Trace enables users to track how requests propagate through their applications or microservices and receive detailed real-time insights. Now, for visualization, our tight integration with underlying GCP resource pages provide observability in context, where monitoring and logging data is available at the user's fingertips without having to navigate from the GCP resource pages to monitoring or logging services. You can also set up performance and reliability indicators and set up alerts and notification channels for proactive monitoring. So let us now focus on some of the exciting capabilities that were released recently. So I will first look at Cloud Logging. The Logs Router provides centralized routing of logs that directs logs from different sources to different destinations. Logs can be directed for storage in log buckets, in Cloud Logging buckets, sent to BigQuery for analytics, or sent to GCS for long-term retention. So for example, if you want to consolidate all your database logs from across all projects, you can configure the Logs Router in a fashion where all logs from across all projects for the databases are sent to one central log bucket. You can define policies on these log buckets. Each bucket can have a regionalization policy, a retention policy, and an access control policy. Now, if you decide that application debug logs are to be retained, let's say for 15 days, but access logs are to be retained for 1 year, you can create appropriate buckets and specify retention policies on those buckets. Each bucket can also have access control policies, both at a log event level as well as a field level, providing you fine-grained access control of these log events. Logs-based metrics enable customers to derive metrics from log events by doing one of 2 things. Either by counting the number of log events that match a certain pattern, or by aggregating values from a field across different log events. Log-based metrics can be used for visualization, charting, alerting, comparison over different timeframes, and defining SLOs, just like any other metric. In addition to defining alerts on logs-based metrics, users can also define alerts directly on patterns observed within a specific log event as well. Lastly, there have been numerous UX improvements, starting with the new Logs Viewer, the Fields Explorer, the histogram view, and a live tail view that shows a real-time streaming view of your logs from across all your projects. Other improvements include Google's recommendation for suggested searches, as well as the ability to save and share log searches within a project. Switching over to monitoring, there have been significant improvements there as well. So the out-of-the-box GKE dashboard offers a comprehensive integrated view of metrics, logs, and events across your Kubernetes objects. It automatically identifies the top N unhealthy entities for each Kubernetes object category. The GKE dashboard relies on a relationship graph that understands how each Kubernetes object is related to other Kubernetes objects. The graph enables users to perform filtering in the GKE dashboard. For any given incident or alert, for example, it is easy to find the correlated metrics, logs, and Kubernetes events by using filtering that is based on this graph. The monitoring query language, or MQL, offers an expressive interface to the time series data that is actually stored in cloud monitoring. MQL uses a set of powerful operations and functions to perform time series analysis that was not predetermined when the metrics were defined and or captured. You can compute ratios, you can compare values over time, you can compute arbitrary percentiles rather than just being fixed on a 95th percentile that you may have captured just early on in the process. The new dashboard editor makes it easy to create custom dashboards. With a variety of new chart types and the flexibility of organizing the charts, we have made it really easy to create custom dashboards. Recently, we also introduced a new type of chart, which is called an alert chart. That enables users to add a specific metric and its correlated alert threshold to any custom dashboard. And last but not least, I would like to mention that the agent lifecycle for collecting logs and metrics has been dramatically improved as well. Now, while I said earlier that you do not need an agent for collecting metrics and logs, system metrics and logs, but when you have to collect application metrics and logs, you do need an agent. We have just recently released the unified ops agent that combines the monitoring and the logging agent into one, thereby simplifying the overall lifecycle management aspects and the configuration aspects of collecting logs and metrics. Service monitoring is a new area that enables users to adopt Google SRE principles. Developers and operators collaborate to come up with service level objectives for their services. They can define and track these SLOs in service monitoring. So the whole process consists of 4 simple steps. First, you have to define a service. Second, you select a metric for which you want to measure the service level objective. This could be a latency metric, an availability metric, or some other metric. Third, you define the SLO that you have agreed to between development and the operations teams. For example, you may want an SLO that ensures that 99.5% of the time, your service should have the P90 response time to be less than 100 milliseconds. Lastly, you specify the compliance period over which this SLO is evaluated. It could be a day, it could be a week, or it could be a month. For GKE users, we have made the process much more automated and simpler. First, we automatically discover services that are deployed in GKE. We also recommend which metric to choose for latency and availability to define the SLO. These SLOs and error budgets are also integrated into the GKE dashboards, so users can get access to all of this information along with other telemetry data, including logging, monitoring, and events. So now let us take a quick look at what's coming next. I will primarily again just focus on GKE related capabilities. So first, we have our focus on making it much easier to ingest application metrics, including one-click ingestion plus out-of-the-box availability of popular application services, including Nginx, MySQL, and a variety of other open source software. Second, we're focused on even tighter integration with GKE. So to provide a richer in-context observability of all of this telemetry data within the GKE UI pages itself. Now, one of the very important integration will be historical reporting of GKE objects. When developers are troubleshooting a problem, for example, in a production environment, having this information and being able to correlate it with logs and metrics from that particular time frame is extremely powerful. Third, users will be able to define SLOs on application metrics that I referred to just a second ago and correlate infrastructure alerts with SLO alerts. We will also be making recommendations on how users can define these alerts. Last, and probably one of the biggest area of investments for us would be in the area of log analytics. The cloud logging service will use Google BigQuery as their default repository. Now, once the logs are stored or ingested into BigQuery, users will be able to run SQL against these logs and perform analytics capabilities that are supported by SQL. Users will also be able to use BQML and LookerML to build their own ML models on this log data that is ingested into BigQuery. Now, once the operation data and the business transaction data is aggregated and in one place in BigQuery, users can also include these logs in business analytics. So in summary, 3 key takeaways from this short session. One, CloudOps provides SREs with deep integration with GKE to make it easy and productive to troubleshoot problems. Two, SREs can set up and monitor SLOs for their services and track error budgets using cloud operations. And thirdly, with several out-of-the-box capability, and now with the unified ops agent that I talked about, collecting and analyzing telemetry data has become simpler than ever before. Thank you.
Hello, everyone. My name is Harish Jayakumar. I lead the Application Modernization Solutions team here at Google. So welcome to my session. So to first start on what is solutions. So we saw a lot of great content that was talked about, which was all the new things that we've been doing on the product side. What we do with the solutions is basically take all the greatness from the product team and try to create a customer-focused problem for which we can build these solutions around. So although we have all these products, customers don't think in terms of products. They always think in terms of what is the use case? What is a problem that I am having that I should be able to solve? And that's where these solutions come into place. So I have here a subway map on how we think about how we want to go and approach talking to you all. We start with doing what we call as an assessment of where you are in the spectrum. So it starts off by either be doing an application assessment with you to find out where your applications are and how we want to go take you on the modernization journey, or we do your DevOps assessment, which call as CAMP, which I'll talk about more in detail, to find out where you are in your DevOps maturity. And based on that, we are able to tell you, hey, you probably have a traditional applications problem or an issue. Like you have a lot of legacy applications, which are Java or .NET. Let's help you modernize them. Or maybe we need to work on your accelerated app dev and delivery. You have a CI/CD thing that they could work on and treat those things. You see here, there is specifically no products names that's called out because we want to think about solutions, but we still use all the goodness of the products and the features and the demos that you saw before this. So as of now, the team's about a year and a half old, and we built a lot of these solutions, and we worked with tons of customers around this. The solutions that you're going to see here, we've already been working with them and trying to help them on their modernization journey. But what's coming up? What's in our roadmap? To begin with, first, all these solutions that we build, customers really, really enjoyed this top-level app modernization methodology. Now what they want as the next steps and what we'll be working on, we are building through this rest of the year, is basically more prescriptive methodologies. How do I take my WebSphere application inside the Java spectrum and get rid of my licensing? How about I go after my ASP.NET applications? How do I use? So what they're asking for is more deep level technical assets, which is what we're focusing and working on. And you'll start seeing that pretty soon in your hands. This includes a combination of blueprints, Terraform templates, reference architectures, demos that you could try out as well. Second, more platform modernization tools and guidance. So end-to-end platform modernization and migration. For example, we have a lot of customers who are trying to get off either PCF or OpenShift to move into platforms like Anthos and GKE. So we're working on an end-to-end approach and tools to help you all migrate for that. What we're also doing along with this is we love to work with you on actually doing workshops. So we can do a workshop with your team where you can learn with us hands-on keyboard in hands, and finding out how you can actually do these migrations as well. And then finally, I talked about these workshops that we're expanding it to finding out where your apps are, where your value streams is, and the CAMP pieces. And what this is basically, we have a lot of customers over the past year come to us and said, this is great, but I really don't know where to start. So all these are the three offers that I'm talking about. App rationalization is basically, it maps out. We spend about 90 minutes with you and we find out where you are in the application landscape. The DORA workshop on the DevOps side, the value stream mapping is more the business side of it. So a quick snapshot of what we've launched already in 2020. These are package solutions that's available for you. We give you value calculators. So even if you want to be able to go back to your leadership team and show them, hey, here's the value in the solution, we can quickly sit with you and generate the value associated with it. We can give you customer references, everything that you want. I'm not going to go into each of this in detail, but pretty much the Anthos GKE solutions on Java, Java CI/CD, acceleration app dev, and even on mainframe as well if you want. Next slide, please. Okay. What are we planning for 2021? We just released actually the .NET solution. So we'd love to work with you if you're interested in talking about your Microsoft workloads and how to modernize them. We're also working on a multi-cloud platform. So this is using Anthos as a basis. We're trying to work with you if you're looking into a multi-cloud solution. We'd love to work with you on that as well. We have competitors. We're trying to come in and get off OpenShift. We're trying to help them as well. We had a lot of talks you must have heard before me about the shift left security. We built a great solution end-to-end along with workshops for it, and also have solution approaches for DORA as well. Now, with that, I'm moving on to the next topic, that's CAMP. So let's talk about CAMP. What it is was that, so DORA is a company that we acquired back in 2018, and it focuses on the DevOps approach. So it's basically a pioneer in helping organizations achieve high DevOps and organizational performance with data-driven insights. So we worked over the past 2 years with very select customers to help them analyze where they are in the cycle. But then we had customers come back and said, hey, this is great. This is telling us where we are. Could you also help us on taking us in the journey? So then we went back and we said, well, we've been doing this for almost 2 to 3 decades inside Google. So we said, let's take the practices that we have inside Google and combine that with the assessment in a customer. And we came up with a program called CAMP. So CAMP is basically taking all the goodness together. So once we finish the assessment, we also take you to the journey and walk you through how you can achieve that maturity. And we help you improve the practice across 4 dimensions. That's the process piece. And then every time we also measure it. We also help on the technical side. And most importantly, and I'm hearing a lot more on this from the customer side, is also how do I go and do the culture pieces as well? So we focus on all these 4 as a tailored program to work very specific for you and how to help you out over there. This is available in the DORA website. I'm not going to go through this, but basically based on that, we can actually help you achieve on these 4 factors of deployment frequency, lead time for changes, how to time to restore your service, and constantly try to get you to that elite performer inside your organization. Here's a public customer, Verizon. You can see their code. They gave us a way to measure things that they couldn't measure before. Now they have visibility into your software engineering cycle. And there's also 3 other customers that I'm going to quickly run through as well. Here's the business impact of Vendasta. They actually went through the CAMP program, and now they're able to improve their daily deploys by 30% and 150 plus more deploys per day as well. The New York State, this is just like Vendasta. Basically, they were able to use CAMP. So most importantly, now with the COVID situation and shelter-in-place restrictions became, the New York State unemployment system suddenly saw a spike with never before volume in unemployment claims. So then they teamed up with the Google Cloud's team to roll out a new unemployment website. This team used the Spring Boot framework from our Spring Cloud GCP library to easily leverage all the services like PubSub, data store, cloud logging, and so on. And so then they're using Cloud Build for integrated CI/CD, and they use GKE. And they saw an uptick of 1600% increase in web traffic compared to the typical week. And this happened really, really quickly, all because of CAMP. And then the next one is Media Market. So this is a German-based multinational electronic company with over 1,000 stores. They're in Europe, and we're able to reduce the cost by 40% just with Cloud Run. Again, this is because of camp. So next question people ask is, how do I go camping? It's 4 phases. First, we start by assessing where you are. Then we show you how to plan, how we can improve these things. And then we pick 1 or 2 capabilities, very specific based on the assessment and working with you. And then we say, how can we improve those 2 or 3 capabilities? And then we measure. Lastly, I always want to say, it's not like do these 3 things and then you become an elite performer. That never happens. So this is a constant loop. So as you can see in the picture over here, and we want to continuously get you to that improvement phase as well. And we'd love to partner with you and help you on this journey. So if you're interested, we'd love to work with you on camp. Please reach out to us. And that's the last slide. So let me wrap up, everybody. So thank you all for joining us. We truly, truly appreciate it. I know we discussed a ton. So where do you get started? So here's the resources. So if you have not already upgraded, please consider doing so and check out the latest features with Anthos. If you need upgrading help, we're here to help you along with our partners. Second, also connect with us on the Anthos product management team. We're excited to invite you to apply to our Anthos Fellows program and also on the Google Cloud customer community call that's mentioned by most of the speakers on this call. Lastly, if you love camping, I want to talk to you. So please reach out to me as well. With that, thank you all for joining.